Hi, guys. Welcome back to a brand new episode of the Clear to Send podcast. This is Francois, and I'm here today with Roel. Hey, Roel, how are you?
Hey, I'm good. How are you?
I'm very good, and I'm happy because today we're actually starting a new series of episodes, and we thought it would be nice to go back to the basics and have a few episodes that talks about basic concepts of Wi-Fi for those of you who are new, or sometimes we get asked about you know to talk about basics, so we could reference to these episodes in the future. So we're going to start this little series, and we're going to start today by talking about the Wi-Fi standards and the different technologies, the evolution of the Wi-Fi technologies over the years. And then this series will continue, and then we'll talk about Wi-Fi channels in the second episode. In the third episode, we'll talk about Wi-Fi security and encryption. And in the fourth episode, we'll talk about optimizing Wi-Fi performances. So stay tuned if you want to hear about all of these basic topics, and then throughout the year we'll do more series of episode like this to talk about different topics, probably more specialized, but today we're
Yeah.
starting with the basics.
Yeah, I think it's a good episode for those who are just getting into Wi-Fi. Maybe you're starting your CWNA journey and looking at the different Wi-Fi standards and the technologies that are there. You really have to know that for the exam.
Yeah, and this Wi-Fi it's a relatively young technology. It's about 25 years old, but within those 25 years, it has evolved quite a bit, and it's continuing to evolve a lot. So if you don't keep track of the changes and follow up what's going on, then you can be lost very, very fast. It's not like Ethernet where it has stayed the same for 30 years, maybe now. Wi-Fi is it's evolving quite at a rapid pace. So this is what we're gonna go through today, is talk about the evolution of the technology, the evolution of the standards. And to help us in that process, we've created a reference sheet that you guys will be able to download if you go to the show notes of the episode. You can head over to cleartosend.net to find that information. But we have a little reference sheet that will go through the different standards and the different, technical details about the standards and the evolution of the technology.
Yeah. So why don't we actually start with kind of the history of building these standards? I think that's a good way to
Yeah.
start off when we hear things like Wi-Fi 6, Wi-Fi 5, but then diving into the actual standard names like 802.11a, B,
Mhm.
G, and maybe even why we don't even see an 802.11c. I don't know.
Yeah, that's a good question. Yeah, so when we talk about the Wi-Fi standards, we're actually talking about standards created by an organization called the IEEE. And the IEEE is an organization that creates networking standards. They organized in different groups, and the group responsible for working on anything Wi-Fi related is called the 802.11 group. So that's
Mhm.
why when we look at the standards, it always starts with 802.11, because anything that this group produces goes under that 802.11 naming. And then obviously the standard is not just one specific specification. It's a group of specifications related to different topics, Wi-Fi topics, I guess. And in order to organize these different topics, technologies, they create subgroups, or they call them task groups. And whenever they create a task group, they will assign a letter to that task group. So the first one was 11A. So they assigned the A letter to that group, and that group was responsible for working on one of the first generation of Wi-Fi. And then whenever this group is done the work, they publish a document where they detail the results of their work, and that becomes ratified amendment. And then once in a while, a new version of the standard comes out, is updated, and they kind of include all of the ratified a new ratified amendment into the general standard document. And that standard document, you can go on the IEEE website, ieee.org, and you can download it for free. You just have to search for 802.11 dash and then the year of the standard. So we'll put a link to the latest one in the show notes of this episode. But the latest one is called 802.11 dash 2020. And that's
Yeah.
because that's the last time it was updated. So if you
Yeah.
search, even if you search that on Google, you'll be able to download the document and take a look at it for yourself.
Yeah, it's a and over the years that document has gotten larger and larger as they put these roll up these amendments into the document. And if you wanted to see even the individual, say 11AX, it is on the IEEE website, but I would sign
Mhm.
up for the Explore and maybe you'll get access to it. Sometimes they ask you to pay for these documents. I think they should be free, just regardless, just for people to
Mhm.
really understand how these protocols work and how difficult it can be to understand them. But this is how you and I, Francois, have done previous episodes. We'll download the standard and read through it, and we've done a lot of reading in the past, but over
Mhm.
time it gets easier to understand it. But then with these newer protocols, they get more complex. It becomes some more difficult to understand after that.
Yeah, one thing you realize very quickly when you read these documents that just like any other networking technology, they love acronyms. So you have to build like a list of acronym for yourself so you can follow up and remember what they're talking about. Um, yeah, so that's it's a very technical document. I think that's what you're trying to say, Roa. It's a
Yeah.
very dry and technical document. It's not easy to read. Usually, we never read it from cover to cover. It's more
No,
like
no, not like a
a
book.
search. Yeah, it's not like a book. It's more like a searching document. You would search for
Yeah.
something you're interested
or
in,
or
and
even used as a reference. So if you're trying to figure
Mhm.
out how something works, maybe just looking at the association part of Wi-Fi,
Mhm.
you'll just dive into that. But then you'll find yourself jumping between the different parts of the standard.
Another thing I think that's useful to mention here is every time the IEEE creates a new task group, they will assign the letters to it, but they also track the progress of that task group. So if you Google the 802.11 timeline, you will end up on a website that looks like it hasn't been updated since the early 2000s. It's like a big ugly table, but at least they will tell you, each task group, what they're working on, the status, did they publish any draft yet? Because before the standard is actually ratified, then you have different draft document. So you'll be able to see the progress of the draft, and you can kind of guess what's the next version of Wi-Fi will be just looking at this progress.
Yeah. So why don't I share the what we'll have you download from our website from the show notes, the phi
Yes.
sheet, and we can even talk about that some more. Um, because it all started with just the prime, the 802.11, right? And you can see how far back that is. I think that's as old as my brother. Actually, he's a little bit older than that, but but
Yeah,
that's
these
when Wi-Fi really started.
and so we're showing here on the screen. If you have YouTube, great, you can see it. If you're just listening on the podcast platform, feel free to head over to the website and download the PDF. You guys will be able to download this. But it's pretty much a table where we have referenced all of the different generation of Wi-Fi, and we can detail some technical aspect of it. So, like you said, the first version of Wi-Fi. We called it 802.11 here. Some people call it 802.11 Prime. The standard was ratified in 1997, so that's 26 years ago now, maybe. So yeah, it's a little while ago, and at the beginning, it was just a very beginning only in 2.4. It was using a transmission method called spread spectrum. So we were transmitting over a 22 megahertz wide channel at the time on 2.4. And we had very simple modulation. We're using BPSK, QPSK. So you can guess that the data rate was not crazy at the
Yeah.
time. We were We had data rates of 1 and 2 megabits per second.
Yeah, not
Um,
very high.
Actually, we've kind of simplified this table as well, because in that first version of the standard, they also had another transmission mode called FHSS, frequency hopping spread spectrum. Uh, it it didn't really survive over the years. That's why we don't have it in the table here. But we tried to kind of simplify it. But that was the first version of Wi-Fi, 2 megabits per second. It was great because it was the first version. It was free on unlicensed frequencies. People could use it, but the biggest drawback of 802.11 was the speed, like 1 and 2 megabits per second. That was
Yeah.
just too slow. So very quickly, the IEEE, they started to work on, okay, how can we make this faster and better? And they started to work on two different initiatives at the same time: 802.11a and 802.11b.
Hmm.
Um, 802.11a, the goal was to provide Wi-Fi on 5 gigahertz, right? So that was a
Hmm.
new frequency band. They wanted to use another transmission method called OFDM. You guys have probably heard of this by now, but OFDM was the biggest advantage of OFDM is that you make a better use of the spectrum that you have available, and you can increase the data rate drastically. So instead of doing 1 to 2 megabits per second, you can do 6 to 54 megabits per second over a 20 megahertz wide channel. So a smaller channel, but higher data rate. So that was kind of like the idea behind using OFDM on 5 gigahertz.
Yeah.
Um,
And that's how Wi-Fi got really big for a lot of us, right? As we recommended 5 gigahertz.
Yeah, and I remember the so 5 gigahertz. It's just like 6 gigahertz today. Like it took a while for countries to kind of adopt it, and we have different rules depending on the countries. We'll talk about this in the next episode. But once 5 gigahertz got popular, we had a much better experience than 2.4 because we had more frequency space. And
Yeah.
at the very beginning, I remember 11A was used for everything like voice over IP. Remember, they
Hmm.
had those voice over IP phones, and they would use 11A to make the voice work properly.
Yeah. And
And
just
that was
imagine
yeah.
back in 1999 when 5 gigahertz was available and how much faster that was, and how clean
Mhm.
the spectrum probably looked like as how it looked when we got 6 gigahertz today.
Yeah. And in parallel, they also wanted to improve Wi-Fi on 2.4. So they worked on 802.11b, which was just an evolution of 802.11. Um, they called it HRDSSAs, high rate direct spread spectrum. And the idea was just to kind of improve the efficiency and the data rate. So they were able to use another way of encoding the data bits and increase the data rate to 11 megabits per second. So we went to 1 to 2 to 1 to 11 megabits per second, which was already a pretty big improvement. And actually, we started to see 11B devices out in the field before 11A, even though the name implies, the opposite. And that's because 2.4 was already available. Um, it was just easier
Yeah,
to
using the
have the product out.
existing frequencies, so it's much easier to get that out there in the wild than saying, "Hey,
Yeah.
you need new hardware." So,
Yeah, exactly. And then after a while, they had OFDM on 5 gigahertz, and then they had HRDSSS on 2.4, and they thought it would be nice if we could get the OFDM data rates on 2.4. So that's when they started to work on 82.11g. They gave it the name ERP. So you'll see that each generation of Wi-Fi has a little name attached to it. We call it the PHY name. Um, for 11G, it's ERP, Extended Range Protocol. And they wanted to bring, like I said, OFDM on 2.4. And that's what they did. They brought the OFDM data rate, so,
mhm.
6 to 54 megabits per second, on 2.4. But if you look at the reference sheet, you'll see that for 11G, the supported data rates start actually at 1 and go up to 54 megabits per second. And that's when we can start talking about something that's very important for the IEEE, which is the backward compatibility of the standards. So every time they introduce a new version of the protocol, they wanted to be backward compatible with what was there before. So they introduced 11G on 2.4, but on 2.4 they were already supporting 11 802.11 and 802.11b. So that's
Yeah.
why they made 11G backward compatible with 11B and 11, and that's why the data rates starts at 1 and then goes up to 54 megabits per second.
Yeah, and I think it's important to know about the backwards compatibility, because as we keep moving forward, we also keep, one foot back in order to
Yeah.
support devices that aren't currently at the latest protocol, the latest standard. And that could be viewed as good, but also a crutch for a lot of our environments.
Yeah, for the enterprise Wi-Fi environments, we'll probably talk about this when we talk about the Wi-Fi optimization on episode 4. But yeah, sometimes it can hold us back a little bit, and there are a few tweaks that we can do to kind of help us
Yeah. Just keep an
in that
eye on
process.
that data rate column, because when you keep your lower data rates enabled, these are all the
Mhm.
other protocols you're still enabling by keeping those lower data rates.
And so to put a date on 11G, we're back in 2003. All right, so early
Yeah.
2000s, we introduced this, and at the time we are still talking about 20 megahertz wide
Mhm.
channels, right? Only. And then the big revolution happened with 802.11n, in my opinion. But in with 802.11n in 2007, they started to introduce a lot of technologies that we still use today that really helped us to improve the reliability of the connection and the data rates,
Mhm.
right? So what am I talking about here? I'm talking about MIMO. So we started to have multiple input, multiple output, multiple antennas to have better, I guess, radio RF links. But also MIMO also brings a spatial streams, which means that you can double, triple your data rates by using multiple antennas, and that really gave a boost in the data rates column. So we'll talk about the data rates, but that gave us a real boost on the data rates, and we started to have really good data rates at that time. And also, they introduced channel bonding. So with 11N, we started to be able to do 40 megahertz wide channels, which also helped us to introduce the data rates.
Yeah.
And then a third thing that was big with 11N is the fact that this was the very first version of the standard that was supported on both 2.4 and 5 gigahertz, right? So that was the time where the IEEE said, okay, now we mature on 2.4, we mature on 5 gigahertz. Let's just roll out a technology that we can use on both frequency bands.
Yep. And
Uh,
for me, that's where to date myself, that's where I started with Wi-Fi, 802.11n.
to the 11N, that's when you started Wi-Fi. Yeah, it's and we didn't mention the name, but the name it's HT, high throughput,
Yeah.
right? So at the time, the focus of the IEEE was just like, okay, how can we get more throughput out? And they just call it high throughput,
Yeah. Or if
which
you're
it was.
starting today with Wi-Fi, it's what, Wi-Fi 4?
Wi-Fi 4. Yeah, I should have mentioned those names, I guess, in the reference sheet. But
I don't know.
yeah,
I don't
Wi-Fi
like those
4.
names.
But we'll probably talk about the Wi-Fi Alliance at one point. Um, Yeah, and then one other thing that we should mention here, if you're watching this on YouTube, you've probably noticed that in the data rate column, we don't have a data rate in megabits per second anymore. Now we have something called MCS. So we have MCS with the indexes
Mhm.
starting at 0 up to 7, and these MCS indexes refers to data rates, but because the 11N introduced new technologies, channel width and special streams and such, the data rates will vary depending on your channel width and the number of special stream you use, and also something called the guard interval. But you can check out the MCS index.net website, and you'll be able to see what these data rates are,
Yeah, we'll
and
link
then
to
you can
that
compare.
also in the show notes, because it that table that you've worked on, Francois, with with the rest of the newer protocols, it's a pretty large table to look at.
Yeah, and you can really see if you look at the MCS .NET website, you'll see different colors, and the different colors refers to the different generation of Wi-Fi. So you can really kind of tie it together and see the evolution of the data rate over time.
Yeah.
But if I give you an example, if we take MCS 7 for a two spatial stream communication over 40 megahertz wide channels, we have 300 megabits per second, right?
Mhm.
So that's not even the max supported by the standards, but that's something you would kind of see
Yeah.
in the world in the real world.
And with
So,
802.11n or the high throughput, this is where I start to see Wi-Fi become more complex because we're now dealing with spatial streams.
mhm.
You've got MIMO, all the number of different data rates that you're working with. Think Wi-Fi really starts to get bigger, faster, a lot more to think about when it comes to even selecting what data rate's going to be used. The protocol itself becomes more complicated, and this is where we start to see the standards document start to get larger.
And also the frequency band. Remember designing for 5 gigahertz,
Mm-hmm.
where I remember starting designing for 5 gigahertz, and the customer had like a 11B installation, and
Yeah,
we would like easily triple the amount of APs, and they're like, "What do you mean we have to triple the amount of APs?" So like, yeah, welcome to the future.
yeah. This
Um,
this is what helped enterprises get you out of being tethered from your desk, right? With the Ethernet
mhm,
cable, you're now able to move around with a
mhm.
laptop. Although it's probably pretty big laptop at the time, right? A pretty heavy one, but
Yeah,
hey, it allowed you some freedom.
yeah. 11N was the big, I guess, the big
The
revolution in
catalyst.
Wi-Fi. Yeah, catalyst. Okay, after 11N came 802.11ac. So this one got ratified in 2013. And this one is called VHT, very high throughput, right? So as you can see, it's similar to 11N. And that's because AC is pretty much an evolution of 11N. Like they didn't really
Yeah,
introduce anything major that was
yeah.
new. They just kind of pushed the limit on everything they introduced in 11N. So we got more
Try to
spatial
make it
streams. We got
faster.
Yeah, exactly. We got a larger channel width. Um, we got a new modulation technique as well. Um, but I think the biggest, looking back at it, now from the experience we have, the biggest impact that 11 AC had on the Wi-Fi on our Wi-Fi networks is the fact that AC was only supported on 5 gigahertz.
Yeah,
So, and any new Wi-Fi devices from that moment started to support 5 gigahertz. Um, I shouldn't say all, but most Wi-Fi
yeah,
devices, I guess, that we started to see as starting with 11AC, started to support 5 gigahertz, which kind of democratized like a full generation of Wi-Fi devices that supported 5 gig. And nowadays, we can be confident to do 5 gigahertz design in an enterprise space. We're pretty much sure that everything is going to get covered
yeah.
except the corner case IoT device stuff.
Yeah, I
Um,
would say this is when a lot of our devices are AC.
mhm,
So when you talk about designing, Francois, like there were so many products developed that
mhm,
that were 5 gigahertz capable, and this was really the era of, hey, we must put all our Wi-Fi on 5 gigahertz, and because of that big jump in the channel width, right?
mhm,
Even with Apple devices, like I think this is when we saw Apple releasing their document saying, hey, here's how we prefer um, Wi-Fi. If we see 160 megahertz wide channel, that's what we prefer. Like the larger
mhm.
the channel with the higher the data rate, the better Wi-Fi throughput we'll have. And AC was like, I think it's still like the biggest rollout is all these
Mhm.
devices with that are AC.
And we still see a lot of AC devices today, and a lot of Wi-Fi networks as well are still AC today.
Yeah,
So, um, also one thing to note here at this point, I don't think we've mentioned it since we started, but the standards will tend to support a lot of things that are not necessarily used in the real world. So you'll see that for instance in AC they introduced 160 megahertz wide channels. This is great because you can push the data rates and all of this, but in the
Hmm.
real world, it's not very doable in most enterprise environments because it limits the number of APs that you can use. It
Yeah.
limits your channel reuse. Um, so in most enterprise environments, we still use 20 or 40 megahertz wide channels maybe.
Hmm.
So these new, some of these new enhancements, they don't really apply necessarily to the enterprise Wi-Fi space. But we get other benefits. Like with AC, we got 5 gigahertz devices. We also got a new modulation technique 256 QAM that we started to use, and we still use today. So we still get benefits from these new amendments.
Yeah. And I think AC was really just a start to where we are going to next. So when we
Hmm.
talk about the next two protocols, that's what set the stage for those two.
Yes,
So when
and
you talk about
after
160 megahertz wide channels, we weren't using it with AC, but you
yeah.
may start to see it with BE.
Yeah, exactly. And sometimes they reused, sometimes we start using different techniques that had been defined like 10
Yeah,
years ago
exactly.
and stuff like that. So it's never lost. Okay, so if we move past AC, we are now reach 802.11ax. So this one got ratified in 2021. And at that time, the IEEE, they wanted to kind of shift a little bit their focus. So instead of focusing on, making the Wi-Fi connection faster, they wanted to focus more on the efficiency of the communication. So they did a lot of work around the efficiency of the communication. That's why they call that standard HE, high efficiency. And we got something new introduced. Oh, not sure why my camera does this. I think it's
You
I guess
really
you'll have.
like AX, huh?
Yes. I think I have those reaction enabled on my Mac. That's why it does this. You guys will have to watch the YouTube video to see that. Um, so yeah, so they introduced something called OFDMA, which allows multi-user communications between the clients and the AP. They also improved something called multi-user MIMO. They introduced a new modulation technique, a 1024 QAM, and also they introduced support for 6 gigahertz,
Hmm.
which it's a big deal for us now. But that was the first version of the standard that supported 6 gigahertz,
Yeah.
and AX is actually supported on 2.45 and 6 gigahertz. So you could say it's the first version of Wi-Fi supported on 3 different frequency bands, um, and yeah, and all in all, that helped us to improve the data rate, but the efficiency also helped us to support more clients within one
Hmm.
channel, and that's something we didn't really see at the beginning. And I know you and Aurora, we talked a lot about it on the podcast and all of this. But now, if you look at your networks now, you'll see, especially in high density environments, if you have a AX, you'll see that you can indeed support more clients
Yeah.
within your channels. And if you start doing throughput tests, you'll see that the throughput is actually increased compared to what we had previously. And the more we have those AX devices, obviously the better it will become. And we can really start to see the benefits of
Yeah.
AX today, a few years later.
I feel that AX was not as big as AC, but it did. What was big about AX was the integration of 6 gigahertz and
Hmm.
OFDMA, which is borrowed from the cellular world. But a lot of people were still, I feel, had mixed feelings about upgrading because they were still on
Hmm.
AC, but weren't seeing. They couldn't see the benefits of AX yet, right? Because AX itself is difficult to understand and even difficult to verify, like, hey, am I seeing multiple
Yeah.
devices on the same frequency? We've had different times at conferences difficulty trying to capture that and see it.
Hmm.
And so with AX, I feel that this is where Wi-Fi gets too complex and difficult to verify how things are working. We have to rely a lot on the vendors to and trust that they can do it. But I think maybe as we keep going with these protocols, maybe we'll have the tools. I think those are still being fine tuned and developed.
Yeah. And I can, I did some, in the past when we used to do throughput test, usually we would see that, in between the throughput we can push through a Wi-Fi connection and the layer 2 data rate, we would have like a 50% overhead, like loss.
Mm-hmm.
I did some tests recently and that was on 6 gigahertz. So on a clean RF environment with AX, I was able to get like 75%
Mm.
throughput compared to the data rate. So we can really see an improvement there. And this is only good for us. Like I think in the future, especially 6 gigahertz it will really give like a different user experience. It will
Yeah.
be that big that the user will kind of notice. um, you probably did a few 6 gigs deployments as well, but when you start deploying larger channels and clean
Mm-hmm.
RF environments and you start seeing like consistent like 400 500 megs over Wi-Fi, you're like, wow,
Yeah.
it's
I'm
like
not used to this.
it's and I'm talking throughput, I'm not talking data rates.
Yeah.
You have data rates over 1 gig,
Yeah.
which is for us it's like, if you go back 10 years, I was like, wow,
Yeah. It's
that's
crazy.
amazing.
Like
Yeah.
it's a big step up. And I feel that's what AX is a step to the higher throughput, right? Because AX is high efficiency. We needed that efficiency put in place in order to get to much more higher throughput, much more higher data rates, as you'll talk about with BE.
hmm and I think AX will also help in very large and like high capacity, high density environments.
Mm-hmm.
Yeah, and then and the latest one we have in the table here is the latest kid on the block, I guess, the 82.11be. And 82.11be is not yet ratified. It should come this year. Maybe it will be, as when you're listening to this podcast. The name for it is, they went back to the more throughput, so they
Yeah.
called it EHT, extremely high throughput. So you can see that it's engineers choosing acronyms here. um,
It's
and
easy.
and this one, yeah, this one is it's what we call the Wi-Fi 7, I guess. This
Mm-hmm.
one is supported on 2.45 gigahertz and 6 gigahertz. um, for the transmission, we're using OFDM, OFDMA, similar to AX. They did introduce a few different things. They have a new modulation technique called the 4K QAM.
Mm-hmm.
They have more spatial stream, even though I don't think we'll ever use 16 spatial streams, but they did introduce that. They pushed the channel width as well to 320 megahertz wide channel.
Yeah.
And then they introduced a couple of other technologies, something called MLO, multi-link
Yeah. There's a lot of
operations.
features that are added for Wi-Fi 7,
Mm-hmm.
which
A
you don't
lot,
see it on this table, but we'll talk about it in future episodes.
yeah, in this table we just kept it very simple to the basics, but you can see that the data rate increases a little bit, mainly due to the new modulation technique that
Mm-hmm.
we might be able to use on 6 gigahertz. I haven't done much of Wi-Fi 7 work yet, so I'm not too sure how much of that will be used in the real world, but I'm expecting
Yeah.
4K QAM, maybe um, MLO used in Wi-Fi 7. And
Yeah.
also Wi-Fi 7 is the first generation of Wi-Fi that supports 6 gigahertz from the get-go, because
Yes.
AX, we had like kind of
It's
a
a phase two.
second, yeah, phase 2 with support with 6 gigahertz. Wi-Fi 7 is just there, and I'm
Yeah.
guessing that every Wi-Fi 7 devices will support 6 gigahertz, which will give
Yes.
us another,
A big
another
boost too.
AC
Yeah.
type of event where we're going to get a whole new set of devices that support 6 gigahertz, helping us to
Yeah.
take advantage of that frequency band.
Yeah. And I feel that this is where we see a lot of folks who have AC deployed today will probably upgrade to is Wi-Fi
Mm-hmm.
7 APs. And then that's when we'll see this big boost in Wi-Fi, because there are Wi-Fi 7 devices coming out now that support, 802.11be. I have one that's still in a box yet to open and test, but we'll start to see what is supported. But it'll be interesting to see what comes after BE, right? And what they support. And whether or not that'll be the next stepping stone for where we'll be. I'm just looking for that next AC event, right, where all the devices are that one protocol, and that's what we're using as like, okay, this is a solid phi to be using on in our environment.
Well, actually, if you guys go to the first, if you click on the first link in the show notes, the IEEE timeline, you'll be able to see what's coming next. We didn't include it here in the reference sheet, but they have something called ultra high reliability. Okay. 802.11bn. That, might qualify for the next version of Wi-Fi.
Yeah, I can see that.
I don't
can
know.
see how, because everyone needs the reliability now. They need more consistency in Wi-Fi, super low latency. So I think this is a great reference sheet. Francois created it. He did a great job. And I think it's a good start to the Wi-Fi basics and all the fundamentals that we need. Because I think, having talked about the latest protocols for a long time, it's good to go back and see where Wi-Fi started, how we got here. And it might even drive how you make some of your decisions today with upgrades or the types of devices that you have and what they support here on this table. It's good to look at that for your APs, your infrastructure, and also for your clients, your devices, and you'll see where you're at on this reference sheet and how you should approach the next protocols that come out.
All right, so that was episode 1 of Back to the Basics. In the next episode, we'll talk about channels and frequency band. Okay, so stay tuned for the next episode. Thank you guys for listening.
Yeah, and we'll see you in the next episode. Thanks, guys. Bye.
Bye-bye.